Thank you, Chairman, for the kind presentation, and good evening. And today I'm here for talking about the FTIR analysis and HyperSpectral Imaging applied to post-consumer plastic packaging, characterization, and sorting. The study is addressed to utilize an HyperSpectral imaging based in order to identify polymers as resulting from a recycling process. You know, everybody, the post-consumer plastic packaging wastes represent one of the main sources of recovered polymers. The application of recycling strategies can represent an opportunity to reduce not renewable raw materials utilization, carbon dioxide emissions, the amount of plastic waste disposed of. The PVC detection is important because heavy fraction recovery is finalized to its further reutilization as SRF, solid recovered fuels. On the left, can you see the samples of the plastic packaging waste? The material under investigations is constituted by heavy fraction from a waste plastic sorting plant. The feed is composed by PVC, PS, PE, PP, and PET. The need-based sorting is systematically applied at different stages of the process in order to identify and recover the different polymers. The need-based have out results a light fraction and a heavy fraction, the zinced. The zinced fraction is the SRF and is characterized by low dioxins and hydrogen chlorine gas emissions. These latter characteristics strongly linked to PVC presence. A reference of 2 kg of zinc product for the started analysis was mixed with the tap boiling water to break up the particles in order to liberate the agglomerates, because the reference sample is composed with, for example, plastics with aluminum and iron. Now the polymers were manually sorted to generate a family of reference after a zinc fluid separation, utilizing 2 different solutions, water and normal salt, and sodium polymers SPT. The equipment tools utilized is FTIR Spectrum 100 and HyperSpectral Imaging technology utilizing a camera, inspector, and 60. The range on the work is 1000 and 1700 nanometers. The spectral resolution is 5 nanometers for a total of 121 wavelengths was utilized. The HyperSpectral imaging combines the advantages of the spectroscopy and the imaging techniques. Is applied to post-consumer plastic packaging can be very powerful due to the capacity of information recordings or the limitation problems involved in sampling operations. HyperSpectral imaging allows to qualitatively and quantitatively evaluate the effects of the interaction of light with organic and inorganic materials. This is an example of the image cube, and all individual spatial and spectral images could be picked up from the hypercube, and the spectrum of each pixel of the image in a specific position can be extracted. The advantages of this technology is not sample preparation, is not invasive and non-destructive, fast acquisition time, complete spectrum for every pixel, saving in labor, time and reagent costs, several constituents determined simultaneously, qualitative and or quantitative measurement, and detailed map, composition, chemical images. And this is an excellent approach to perform both quality control and classification actions on different types of materials. The device is realized by an Italian company, they name it DV. This unit was specifically designed for setup for both for both industrial and research use. The device is fully controlled by a PC unit equipped with the spectral scanner acquisition software. In the picture on the left, on the right, can you see the new spectral camera, the optic, the energized source, and the samples analyzed. The HyperSpectral processing is developed, have a procedure. We have the time of scanning, the time of PC unit for processing the data. Spectral data have been analyzed using a toolbox. This is PLS Toolbox 7.0, running inside MATLAB, adopting a standard chemometric techniques. Now, with this toolbox, I have the spectral preprocessing. I can class a selection of ROI, region of interest. I can develop a PC analysis, and after PCA, I have the PLSDA analysis. The PCA is a method for exploration data, and PLSDA is applied for pigment binder mixes classifications. HyperSpectral images typically have 100 spectral bands, large degree of reduction in the data, and PCA is optimal to data compression, only little information are lost, and simple representation. The PLSDA is a supervised classification technique. On the left, can you see the score plot referred to the PCA analysis, and the first picture is the curves. Now I have the FTI analysis results for every particle analyzed. Is 125 particles analyzed by FTI analysis. To analyze to each particle was analyzed by Wiesner HyperSpectral Imaging to build an ad hoc spectral reference library to utilize for recognition. In the table, can you see this is the other particles, for example, iron, cottons, or paper, but is not studied in this work. The focus is only for the particle plastics. Now I have this is the first step for PCA. I have on the left I have the reference of samples. These 5 types of particles, polymer particles, PVC, PS, PE, PET, and PP. On the right, you see the region of interest selected for each particle. The spectral data referred to the investigated particles, preliminarily identified by FTI spectroscopy, were preprocessed to enlarge the spectral attributes of different classes of material. On the bottom of the slide, can you see the average raw spectra for every type of particles. After I have the preprocessed spectra applied for this type of model, have the second derivative, standard normal variate and mean centering. And on the right have the curves of this preprocessing. And after this have the score plot for each particles. In orange I have the PVC, PS, in blue PE, in red maybe PP, yes. After the PC analysis, I can develop a model to classify every particles. The PLSDA is used to find a model able to perform an optimal discrimination among classes of samples and for prediction in new image. On the right have the new image or prediction image of the starting from new polymer samples on the left picture. Have the investigated polymers and the most probable image. PLSDA model allowed to realize a good classification for all the samples. In conclusion, the study demonstrated that the proposed HyperSpectral imaging based approach in the new range can successfully utilize to set up in real-time analytical control strategy to perform a continuous monitoring of the composition of different flow plastic waste streams resulting from industrial processing with particular reference to PVC identification. That's all. Thank you so much. Thank you.